Today we're going to do some hardware changes. None of these are, we did get a good print off of the thing. So obviously the printer works the way it is, but there's some things that could be better. There's some things that are just kind of fun to do, some things that are kind of preventative to do. Some of these are free, so well, not totally free. I guess you pay for some plastic, but let's get this off the screen so you can see. It's all in the way. Printed out some pieces, actually lots of pieces. Printed that. Let's get them all up here. These are different things that we're going to add on today. Let's see, I think that's all the stuff I printed, and then there's some parts that purchased. No particular order to these, but I'll just go through them and install them and tell you what they do. And then we'll talk a little bit about the way this thing prints. I have a different Hotend over here. I'm not going to change this one out today. We may do that later, but certainly not today. But this one we'll use as one we can take apart and look at all the different pieces of it to see what's going on inside here. Now this one's a little bit different in the shape and size, a different format, but all the parts are the same. It has the same types of parts. They're just made differently. Let's see. Let's start with some of the printed ones. Let's start with this one. It's kind of fun. And it's a little preventative. So down here, you've got this cooling fan that is cooling the electronics inside here. So at some point, we'll probably take that apart so you can see what's going on inside there. Particularly, yeah, we'll have to because we need to wire in our bed level sensor later in the quarter. We're not going to put it on today. It takes longer. You have to deal with firmware and mounting the sensor itself. So we'll have one class where it's just doing that. We'll add a sensor off. I think we'll put it over here on the side, maybe at the back. I don't know where we'll put it, but it will go and sense where the bed is as far as if it's warped or bubbly or whatever. It'll go map out the bed, and so we'll have to get inside this box. Anyway, inside this box are also the drivers that control all of the little motors and the drivers that are going to turn on and off the heater and sense what temperature we're printing at. Same thing with the bed. So there's a lot of electronics inside here, and if they overheat, then they will not perform correctly. So you'll get things like disaster. The things fail in some way that they can't be repaired. Not as bad a disaster. They just overheat and they don't turn the motors exactly the number of steps or the number of times that they need to. So this is not going to make them stay cooler. What it's going to do is it's possible right now for things to just fall. Maybe you got a little tiny thing and it can fall straight down into this fan and jam the fan and you wouldn't know it. Break one of the little fan blades off, and then you got to figure out a replacement fan. So what this does is it's got a hole here that will sit on top of this. We're just going to screw it under these two screws, and I actually haven't test fitted any of this, so there is a possibility that it looks like it lines up, so I think we're okay. But and then the only way for air to come in is from the front, so you're much less likely to get something down in the control box fan. So that's an easy one to do. This printed, no supports. You might think that, well, it's got this opening here, but the way this particular one's designed, they have these fins or ribs inside here, so that instead of having to bridge, your printer having to bridge from across all the way across there, it just has to make these little short jumps. And you can kind of see inside there is some amount of stringing, like a little bit of drooping in there. You could go in and scrape those out with some sort of knife or screwdriver even possibly. I'm not going to worry about it. They're not loose, so they're not going to just fall in the fan. But if you're worried that they're going to come loose, then you can scrape those out. I'm not worried about it. The other thing I'm going to see if I can show you is, so I didn't print these parts on this printer. So obviously if you only have one printer, then the printer that you're upgrading is the one that you're going to use to print the parts. Now, like I don't know where our little piece went that we did print. Here it is. This came out really well, and I think this printer would be able to print all of these parts. I just didn't have it out running, but I think it would have been fine to print them all. Sometimes when you're upgrading these parts, not as much these days as it used to be, but you would have to print the part so that your printer would print a little bit better, and then you could print a new version of the part. These printers are generally printing well straight out of the box once you assemble them. So I don't think you have to do multiple iterations anymore. So all this does is we unscrew these two screws, find our little Allen wrench. Again, this is just the one that came with the kit. I wonder if, I don't think we want to take a look down in there today. We will get inside there though. There's another screw at the back that finishes removing this cover. So this one's being a little contrary. There we go. So it's just going to go back right on top of there. So this is a super easy upgrade. The print, I printed it at a relatively low or thin layer resolution, and it took right under 2 hours. There's a lot of these, a lot of different form factors. They basically all do the same thing. I chose this one because it has this little arrow on top of. I might paint that to make it show up better, but what it's showing you is it has a up and a down written on it, and then an arrow that's pointing in two different directions. What that is these bed leveling knobs underneath here. You rotate them one direction or the other, clockwise or counterclockwise, to raise and lower each corner of the bed. And sometimes you forget which way, if you're not good at visualizing turning something and then looking at it upside down to figure out which way to turn it. It just tells you, hey, turn it this way to make the bed go up, turn it this way to make the bed go down. So it's kind of handy. All right, so I'm just checking to make sure that it actually did open up in the right spot. So that one's super simple. Nothing to that one. This one is similar, but it doesn't actually have the same function. So over here, let's see. Let's do a little more. This is the power supply. This is kind of like the power supply that would be in a computer. And in fact, the first printer I had, it literally was a power supply from a PC. But it has a similar fan to cool the electronics inside here. Probably things are not going to drop in from the side, but it's a little bit loud. And so what this one does is it kind of redirects it and muffles it. It's basically kind of like a muffler. So we're going to mount it right here. Now this one you do have to be a little careful with, because if you take both of these screws out, then that fan will fall inside there, and you're left with the fan inside the case, and you got to open it all up and fish it out of there, which, it's not plugged into anything, but since we are messing with the power supply, let's just make sure we don't accidentally leave it that way, plugged in while we're messing with it. All right, so I'm going to do one of these and then put it in. Now this one, it's got a pretty thick flange right here, so we may have to find some other screws for this one to work now that I'm looking at it, but we're going to try and see what happens. I got to get it started first though, but it might be that we have to go and find a little bit longer screw. I won't bore you with me searching through all of my random screw parts though. I think it'll hold. All right, so now we can take this one out. If you didn't have it holding, then see, we have a little bit of a problem there. I think we can make it work, but we have to get the mounting hole for the screw. So the fan is a little bit loose in there, right? And so it's wanting to twist around. So this is a little bit tricky. And I think what I want to do is tighten this one up a little, and then I think that did it. It's a little tricky to get all that lined up. Plus, you can kind of customize your printer, assuming you have a color filament that you like. You can, let's see, Yeah, I think we got it in there. All right, so now we have a little bit of a muffler on there. So you can make these different colors or whatever. I had a roll of red filament in the printer I printed it on, and I didn't change it out, so they all came out red. And red and black's kind of nice. In fact, all these little grooves right here, if you really want to be fancy, they do make inserts of various different color, plastic inserts of different colors that you have to buy those. I guess you could print one. I don't know if it would really work that well printed. I haven't tried, but you can insert different things. They make some stick-on LED type things. You can put LEDs on there. I don't have any of that to worry with right now. So this one is kind of important to do because you don't want things falling in there and you having to work on your motherboard for your printer, or replacing the thing. This one's not super important because all it's doing is muffling this sound a little bit. These fans are going to be kind of loud, also not terribly loud, and we can replace them, but they're not. We're going to work on this a bit later. So here, this fan is the one that cools the hot end. So the hot end's, well, sitting in here like this, and we'll talk about this in a second on what parts need to stay hot and cold, or not cold, but not hot anyway. And this fan blows across these fins inside here to cool down this half of the hot end. So the filament is going to come in from the top. It's going to sit, more or less like this, and the filament will come in this hole right here. In fact, why don't we get down closer and look at it up close? So let's take this all apart. So this little thing is just normally there's a piece of tubing, Bowden tube that's going. I don't want to actually insert it in there, but it's going in there, and your filament is coming in here. So this guy is just guiding the filament into the hot end itself. It does have the not quick release, but it does have the little capture device here that you should be able to press in to remove the filament. Not the filament, the tubing, the Bowden tube, however you might pronounce it. And this is the thing that on our printer we put a little clip underneath here so that you couldn't actually push this in, because eventually this tube is in here, and as you're printing, it's twisting back and forth, and it might want to move in and out, and you don't want that to happen. So our printer actually came with little clips that we could clip under here. If yours doesn't, you can print them. They're on Thingiverse, those little clips. I'll have to look for their actual name to sort them out, but they just slide under here and keep this from being able to go in, so that the idea is that your tube won't back itself out. Because if it does, then there's a little gap between the end of the tube and where it actually ends up way down in here in your printer. In fact, let's take this off. So this is the heatsink part that I'm unscrewing right now. Its job is to keep this side relatively cool. It'll heat up, but it'll be something that you could touch while it's printing. If you could reach down in ours, you can't even get down in there, but it won't be so hot that you couldn't touch it. And the idea here is that these fins are having that air from the front fan, or well, it's not always on the front, but on the cooling fan, blowing across it to wick away the heat, so that the filament in here doesn't melt, or doesn't even get hotter than the glass transition temperature for your filament. And all the melting occurs further down in here. So this one actually has a piece of filament stuck down in it still. But anyway, what would happen is this tube isn't going to want to go down in there right now. This one's not really a nice piece of tubing, but it would sit all the way down in the bottom of this thing. And if this backs out, then there's going to be a little gap, or if it's cut crooked, like this is cut not square with the tubing, so there's going to be a gap between the end of this tube and the bottom of the inside of this. This is called the heat break, this little piece, right? Just this piece. I can't unscrew it. It's set in there. I'd have to heat it up to unscrew it. But this piece does come out from this block also. But there would be a gap between there, kind of, kind of like you could see, maybe you can see that there's a tiny little gap if it's cut crooked or if it's backed out any. And as filament gets closer down here, it does get softer, soft enough to melt, and the filament will ooze out of that gap. And then when you try to push new filament in, it's just going to squirt out the side inside here and cause a clog. So if you're ever printing along and it's doing fine until maybe 30 minutes or 40 minutes into the print, and it just stops printing, and you don't see anything wrong, like the filament didn't break, it's not tangled up anywhere, it's just the printer's still running but no filament is coming out, there's a really good chance that that's what's happened. That somehow there's a clog formed in here, and normally the clog on this style printer is because this tube has backed itself out, or this is not cut square, or the fan that's trying to cool this thing is not cooling it, and so the heat has worked its way into here, and now you've got melted filament in here. If I'm trying to push on melted filament in here, it just kind of clogs it all up. So you will probably at some point end up having to take the hot end apart on your printer, and that's kind of normal that you have to do that. Here's a little nozzle. We can get that one out. Again, this is a brass nozzle. Look, there's a piece of filament stuck in there. So these are ones I haven't cleaned out from an old printer. So they're kind of like this, and you've got the nozzle. So this is the part that, in fact, you can even see written on this one, the diameter, I think. This one says, yeah, it's upside down, but 0.4. So by default, most of them are 0.4 millimeter hole inside this thing, inside this nozzle. And the cheaper ones are brass, which is totally fine. So those are totally fine until you start printing in any kind of abrasive material or anything that's gonna wear away that nozzle. Glow in the dark, wood feel, copper feel, all these things that if it says feel in it, then it means it's filled with something other than just plastic. And that filler will usually wear these brass nozzles out relatively quickly. And you won't even, it'll still print, but your prints won't be as nice. What happens is that nozzle gets worn into a larger hole. It may not even be a round hole, so it could be oblong or whatever. So if you do plan to print anything abrasive, anything other than just a plain ABS or PLA or PETG or something like that, then you want to upgrade this piece to something that is more durable, so a hardened nozzle. One of these is $1 or $2, and a hardened one might be in the $10 range maybe. So it's still not crazy expensive, but more expensive. This is the heater block. So normally inside here, in this hole, there is a heater cartridge. So it's basically a resistor that you apply voltage and current to, and it heats up this whole block. Also in here, on this side, there's a little smaller hole. Inside this hole is going to go your temperature sensor. So most of these use thermistors. There might be some that use thermocouples, but whatever, that's not important for right now. It is important that your printer firmware, so the printer itself knows what kind of sensor is in here, but by default that's all set up. You don't have to go changing that. But there's a little sensing element that will basically monitor the temperature so that your printer has an idea of how much power to send to this heater to keep the heater block heated enough to melt the filament to print it. This piece that I can't get the rest of it out, so it's screwed into this block. These are not, these are two separate pieces here. This is called the heat break. And so brass, usually this is aluminum. There are some of these that are a different material when you're trying to print really, really high temperatures. So this setup is good to about 240 degrees Fahrenheit, and it's usually not Fahrenheit, Celsius. It's limited by this guy. So this tube that's feeding the filament in, it's going to go all the way down into here on these style printers. So this is the tube, the Bowden tube goes down into the hot end. Doesn't go all the way to the block, so, but it does go down maybe to right there. If this filament wasn't in there, you could see where it sits. And so this tube is going to start degrade. This is Teflon, PTFE. It's going to degrade once you get to about 250 Celsius or something like that. This piece is the limiter on your printing temperature, at least on the hot end side. Obviously, these metal pieces can survive beyond 240 degrees Celsius. So you'll hear of all metal hot ends because you want to print something like nylon or something that's really polycarbonate, something that you got to print really high peak. So you had to print it at super high temperatures. That is meaning to replace this with a setup that doesn't have this tube go all the way down into it, and it doesn't have a liner inside there. It's all metal. And that at that point, now you're limited by, well, how much energy can I put in there from this thermistor or from this heater? And your thermistor does have a limit on it also on what it actually can measure. The way these things work, outside of their functional range, they're not linear anymore, and so they don't perform very well as far as predicting the temperature that they're seeing. So the heat break's job is to connect the heater block to the heat sink, but with a tiny little connection. So this piece is stainless steel, aluminum, brass, stainless steel usually, and there's a little tiny tube of it right here, and that's the idea, is that there's a very small mechanical connection between the block and the heat sink. And so the idea is that this is going to stay really hot. They do have to be physically connected together, but I don't want a lot of heat conduction between the hot part and the part where I want the filament to just not melt. I want it to melt right at the nozzle down here. And so this is the heat break, and you have to be careful with these because this is a really thin piece inside here. It is steel, but it's very thin right here, and so if you twist on these too much or if you over tighten, then it's really easy to shear that piece or crush it with torsion. So then you're back to an aluminum piece usually, and again, this is the heat sink, so it's getting rid of all the heat. So that fan on the front needs to be blowing on this thing all the time. Whenever the printer's running, that fan needs to be on. And then this guy is just feeding the filament in and keeping that tube inside there. All right, so let's go back to our printer. And let's see. Oh, turned it upside down. There we go. So the fan here is the one that's cooling the heatsink. This fan is the one that is cooling the parts that you've printed. And it was working. You know, we did get our print. It worked fine. But they do have a lot of different little ductings down here. Let's see if I can get this one off so you can see it. Oh, I need a smaller tool. Get my little, these tools that came with it. One of them should be the right size. I think that one's it. All right. Now, again, this is another one I haven't test fit, so I don't know if it will fit exactly or not, but at least you can see what's going on with this duct. Or if I can get it out of there. These are really tiny screws. All right, so this is what's on by default because I just took it off. And what it does is this kind of fan doesn't blow this way, it's going to blow this way. So if you look at the fins on it, you'll see that they're not shaped the same as the blades on this kind of fan. And it's going to send air out, and there's a little curve here that's going to push air across the part you just finished printing, or the layers that you just finished printing. It just kind of blows it everywhere, including on the heater block. So some of that air even goes on the heater block, cooling it down, which you don't want to do. So there are a lot of alternate designs. This is one that I picked up. All these things that I printed here, I put the Thingiverse links in the description for this video. Now this particular one has this little piece built onto it. All of this is basically, see how they built this little circle? This was part of the model. That circle right around there. They built in a part because apparently whenever they printed this, they were having trouble with this part sticking down to the bed, and so they just built in some more area to try and hold it down. Sometimes your slicer can add those for you, but this one didn't. Oh, this part gives you a good example of ringing if we can see it. Let's see. I don't know if you'll be able to see it or not. Yeah, it's kind of going to be hard to see, but I don't think you can pick it up. It may not can focus that close anyway. But anyway, there's a lot of ghosting across the top here, so that print, as the nozzle made this corner, it was bouncing back and forth over and over, and you can see those rings or that ghosting in the print. It's not going to affect what we needed to do. Hopefully, if it fits, it's going to go right under here, which I don't know if it will. It might. It does look like I might need to trim off these little pieces back here for this model fan, which is fine. I can do that. And what it'll do is, so instead of just shoving the air out uniformly, it's going to kind of shove the air into this ducting that's going to force it to go down on the parts that you just printed and away from the nozzle. Now, this particular piece, these are all PLA. This particular piece is probably not going to last very long in PLA because it's so close to the really hot nozzle. You know, it's going to be right in here. I don't know which way the nozzle turned. I think it's kind of more like this. So it's going to be really close to something that's hot. And there's probably going to be enough radiation heat just between the nozzle and this thing to melt this. So we'll have to keep an eye on it. So this part really needs to be printed in ABS or PETG, both of which can be printed on these printers. I did answer a question or two about can these print PETG. They had seen that this this tube for the temperatures you needed to print PETG at would fail, but in general you don't have to print PETG that hot. You don't have to be above 240 to print PETG, but if you did, for whatever reason, you got a roll of PETG that wouldn't print at anything below 240, then yes, then you'd have a problem. But normally PETG will print in the 230 range, maybe even 220 for some of it. So as long as you don't go above 240, you should be okay. Particularly since this tube doesn't go down as far as the heater block. It only goes down into the heat break. It only goes down, maybe to right there. So, and so that should be a cooler spot, much cooler than 240 anyway. But this piece being so close is probably not going to. We'll give it a shot, because all that the worst that can happen is, well, I guess the worst that could happen is that I leave it on there and forget, and I start some really long print, and then during the middle of that print it melts and creates a big mess. But I just wanted to put this on here. So what I'm doing right now is, it had two little pieces right here that for this model fan wouldn't fit, so I just clipped them off. I'm going to clip this thing off too, because it's it doesn't need to be out there. So this is called, oh, there we go. It all picked away. So they had built it where it was relatively easy to remove. And here I'm just cleaning up the bottom of that part. All right, now we should be able, yeah, it fits perfect. And it is really close. Now this, let's see if I have one. I don't think I have one out. But on this particular printer, and I assume on yours also, the heater block itself, it has a silicone sock, basically a covering over it, so that will help keep some of the heat away from our part here. But again, I still think I'll probably have to print this in PETG. Maybe that can be one of our next things that we do, is get PETG to print on here. All right, so let's put that little guy in there. And so the idea with this upgrade, and there are a lot of different ones. This is just probably the simplest one. There are some that totally reroute the cooling, the part cooling. Part cooling is especially important with PLA. ABS, it's actually not used at all for the most part. PETG, it depends. So PETG, the hotter you let it print, so don't cool it, it will be stronger, but it'll be kind of messy. It won't print as clean of an object. But if you cool PETG, then it'll be weaker. It'll still be probably stronger than PLA, but weaker than it could be, and it'll have a better surface finish. PETG is really bad about stringing, getting a little, when it moves from one place to another, leaving a little string of plastic between those two spots. And so when you don't cool it, then it is even worse at doing that. But it is a good material. It prints closer to how PLA prints, and it's not noxious at all like ABS can be. So it is a good material. It just takes a little bit more. Anyway, all that to say that these part cooling fans, there are many to choose from. I picked one where I didn't have to change out the fan. I could use the stock fan, stock mounting hardware, and just unbolt, put it in, and bolt it back in. But do recognize that this one, being so close to the nozzle, may have problems. We'll have to keep an eye on it. Okay, let's look at this side. So far, this is all stuff that we just printed. So we had to pay for the filament to print it, and that was it, in some time. So altogether, the printed parts took 6 hours altogether. I printed this one by itself, and then all the others I put on the printer at one time and let it go. I normally don't do that because if you print like a whole bed full of things and one of them fails, there's a good chance that they will all end up failing. That one that comes loose or whatever will get connected to the nozzle and drag it all over the bed and just ruin them all. The printer that I printed these on, I have more confidence in not doing that, so I let all the others print all at once. All right, so let's see if we can get a good picture of this. All right, so the way that this filament mounts, I kind of like it up here because it's not taking up any more table space, and it's fine, except that it does come off pretty steep here, which is fine, but then it goes in here and makes a almost right angle to get into the extruder motor to send it on to the printer. And this right angle, it used to be that this part was all plastic, and so it would basically just eat a groove into this piece. Now I see that they actually have put a little metal insert in there to at least prevent that from happening, but now the filament gets worn away on that edge as it drug through there. So there's a couple of guides. This one that is going to sit on top of here, and it has just a piece of an old Bowden tube. So this one is not totally printed because it does have a piece of tubing that I scavenged from just a piece I had I wasn't using. There are some that you can totally print that don't use a piece of tubing. They just have it's all printed. The idea is the same, though, that it is going to kind of make this a more gentle angle. So we need to take these two screws and slide this guy over the top of the lead screw and get it mounted in there. So these are they this size? No. Got to find the right size. There they go. Okay, there. This one's a little tougher because it's in side here. It will work. Now, to actually get this to work, I'm going to have to unload the filament because the filament has to go through this tube. So why don't we, it's probably, yeah, it's in the hot end. I don't really want to turn it on, but I guess we need to. So let's go back, and we could just cut the filament and then deal with it later, but let's do it more of the right way. I do have to plug it in. Maybe we can hear a difference in our fans, or if there's a problem, then we can find it now. All right, let's see. We need to preheat for PLA so that we can, wow, this knob is really not the way I like it. You have to turn it, if you turn it too slowly, it doesn't register that it turned at all. That's a little annoying. And too quickly, and you go past the menu you're trying to get to. So all I did is I went in here and I told it to preheat for PLA, basically so that I can get the filament out of the extruder, or out of the hot end, because it's down in there from the last thing that we printed, and it is solidified now, and it won't back out because it's melted in the hot end. So I need to remelt it so I can pull it out so I can change the filament. There are some printers, this one might too, I didn't even check the menu. Some of them have an unload procedure where you just go in the menu and click unload and it'll do all this for you, but we're going to manually do it. So it's at 150. That's probably warm, melted enough for us to get it out of there. I don't currently see any melting happening with our little fan duct, so that's good, but it's just started. So what I'm going to do is I'm just going to release this and pull it out. I couldn't do that before because, like I said, it was melted inside there. In fact, you can kind of see. This is what you want, actually, for it to look like, where you can kind of see where it was melted in the nozzle. Now, when you go to put it back in, you cut that part back off. That's all we needed for that, is turn it back off and get back to our upgrades. I guess we could reload it in a minute, but we aren't going to worry with that. All right. Now, slide this guy down and screw it back in. And the length of this is kind of arbitrary. That is just the piece that I found. So, oh, now it's going to be even more difficult to screw in there. Wow. We may have to, I don't know if I want to spend a bunch of time getting that screw back in there or not, because it's going to be really kind of tricky to do. In fact, I just dropped one of them down in there. We'll have to get that out in a second. Yeah, I think I'll not screw this thing together while we watch, because it's kind of tricky to get in there. It's probably simpler if I raise this up. So that you don't have to deal with this also. Remember, when you're turning these motors, if you turn them too fast, you will apply some current back into your system, which you might not want to do. So, all right, now, so a problem that this has is that these screw holes, or these holes where the screws go, are actually too large for the screws that are in here. And so the problem with that is that it doesn't hold it in place. So, oh, maybe we don't have to screw it in there. Maybe we could have just put it on top. Maybe that's the point of it. And we didn't have to actually screw it in place. I guess it wouldn't go anywhere because it doesn't have anywhere to go. So maybe it doesn't have to. Maybe it's really simpler than I thought don't do the things that I do all the time, because I think you could just drop it in on top without actually having to screw it in. Oh well, that's kind of why I wanted to do these things with you, is so that if there's something like that where, hey, you don't have to screw that thing in, just drop it on top of there, then you get to see that a lot of this is just figuring it out, and there's some trial and error. And the biggest thing is that for the most part, most of the things that you do won't actually break the system. You know, you might have to go back and reconfigure a thing, or you might have to put a part back on that you just took off or whatever, but most of them aren't permanent breaks. That's a little annoying to get that piece out of there, but I think all we have to do is drop this on top, and so that's why the holes are that large. Good to know. Alright, so in that case I will put this back together, because there's not much to putting it back together, just screw it together. It is constantly moving down as I'm trying to screw it though, which is annoying. Alright, now, so just drop it on top of there. And it might even like snap. Well, it won't really snap into place, but I think it won't go anywhere either. I don't know. I don't know if I like that particular one, because it doesn't actually fit over the brass nut here. It kind of sits on top of it. So it's somewhere in between where it needs to be. It either should have smaller holes to screw underneath those screws, or a larger hole to go over the brass piece. So as it is, it's kind of not doing what I want it to do. But I have another one. I have one that's going to go way up here, the upper guide, and how it works, hopefully, is that it just prints out a matching pattern here. It does have an order, so there's a bolt up at the top here, and one of these little pegs is shorter, so the shorter one has to go on that side. And it just taps itself in there somehow. There we go. And then it's got a arm that I guess it needs to go this way. We'll just slide in there, and then the filament can go inside there. It's got a little notch in it, and that will also help this be a not so steep angle. Let's get my filaments, and then we can get our filament in here and feed it back through our system. All right, so you get a, well, look way up there. So it comes out here and makes this. Now this is all warped up because it's been in the printer already, so that's why it's creating problems. All right, those are all the things I printed. All right, let's look at some of the things I bought. One of the easier ones is this bed surface is really good. It's basically a Build Tack, which is a name brand of this particular material, and it would work completely fine. But I have a different one that I want to use. So normally, yeah, it does. Does it have an adhesive? Maybe it doesn't have an adhesive back. Maybe it just sits there, because I don't think that's adhesive at all. So I think you just clamp it on, and then you can kind of use it as a flexible one the way it is with the little clamps. This surface is actually good for PETG. It's good. It's kind of a good generic material to work with, to print on. So it is not bad. But I had another one over here that is just, I want to use it. So this one is from Filament. I don't know, there's probably a lot of different brands of this. It has a sticker that's a big one of those big like refrigerator magnets that's going to go on here. We have to adhesive it down. So some of these things, this one's, it's not permanent. You can remove them. It's just a pain to remove them. So to remove them, you heat the bed up and basically scrape this adhesive off of there. But it is a little bit annoying. So if you do this particular upgrade, then, or I don't know if it counts as an upgrade, but this change, then it's going to be a pain to undo this one. And this is a spring steel sheet, so it's steel. So one of the downsides here, this bed is heated, so there's a heater underneath here. You can kind of look under there and you can see some of the little wiring that's underneath it to heat this thing up. And this is kind of, it looks like it's got a fiberglass back on it, some kind of material like fiberglass anyway. And this one is going to have like this magnetic and adhesive stuff, so they're both going to kind of limit some of your heat distribution that you want. It'd be nice if you could just print straight on this. There are some printers that have basically a metal bed with a little bit of a coating on it, and you print straight on that, and they work pretty well. The problem with those is then if you're ever scraping a part off or whatever and you dig into the bed, you've dug into the bed, the heater, everything. So they're usually, it's a reason why most printers have something on top of the bed. And this one has this magnet and then this spring steel sheet. It is coated with a PEI. So that is a coating that works as when this coating heats up, you run the heated bed, it will basically fuse with, like chemically fuse with PLA and ABS materials like that, and they stick really, really well. So you don't have to worry so much about your parts coming loose mid-print. So if you're printing bigger things or things that are going to warp, or you're afraid they're going to warp because they've got tall, thin walls on them or whatever, maybe you're printing a box for some reason, and it's got thin walls on it, this kind of surface is really good for those materials. It's really bad for PETG though. So printing PETG on a PEI surface is, it works too well. It can bond at the point to where the PETG will rip the thing apart, or it just never comes apart. So if you have a PEI surface or even a glass, so some printers have a glass bed. Sometimes you just get a mirror from IKEA or Walmart or somewhere and print on top of that. In fact, well, they're all mounted now. All these pieces were printed on just a borosilicate glass plate. So the advantages there are that you can get it really clean. Should be pretty flat. The mirrors are nice because the back of them are coated with silver, which is a good heat conductor, so it kind of helps distribute your heat around. But PETG and PET will stick to that PEI and that glass bed to the point that it will rip them apart. So you have to be really careful using PETG on glass or PEI. You can do it, you just need to put something between here and what you're printing. So blue painter's tape, glue stick, some people use hairspray, something that doesn't let it bond directly to the glass or to the PEI. But for PLA, this stuff is really good. So we're going to put it on there and hopefully never have to take it off, because it is a pain to get this sticker off of that bed. In fact, let's clean it off a little bit. It's probably fine. I normally keep a little spray bottle of IPA, isopropyl alcohol, for wiping things down on the printer before a print, just to get any grease off of there. Either that, or last time I think I showed you I had the little alcohol prep pads. We'll do the same thing. All right, so let's try and get this more or less straight, because I think you only really get one good shot at it. And I'm kind of unsure of where it's going to land. And you don't want bubbles in this, so kind of go from one end. That looks okay. Yeah, I think that's fine. And it's got a little bit of overhang. We can trim that off later with a X-Acto or something. So now we've got a magnetic bed. We don't need the little binder clips anymore. There's nothing wrong with the binder clips, but they do get in the way, like particularly when you have them on the front and you're trying to do a purge across the front, or you have them on the side and then they're hitting the frame, whatever. So the main reason I wanted this though is for the PEI surface, because it works really well with PLA. And so now we can just drop it down, print on it, pick it up, and then you know, flex it a little bit to get the parts off. This one doesn't have any good locators on like getting the thing centered, so that's a little bit annoying. We might have to print something to center it up. So that's a super simple upgrade. It's probably the most expensive one of the stuff that we have here. Obviously the 3D printed stuff is basically free other than the filament and the time. This one's probably, I'd have to look, but it's probably in the $20, maybe $30 range, something like that. So you'd really want to print for a while before you just go stick one of these on there for no big gain, because this one will work fine, and it's removable. You just got the binder clips to deal with, and you can flex parts to pop them off of there. So there's nothing wrong with this one. It's actually decently good. Let's see, what time is it? We got time for probably one more. I actually have two others, one of which I'm not sure that I want to do just yet, because I'll show you. Oh, I see some washers that fell out when I took this off. I'll have to put those back. So this cable mess back here, generally it's fine, but it is possible that these cables can get hung on the bed as it moves back and keep it from moving back, or unplug something, or just create problems. And so you want them to stay out of the way. So you want them to kind of stay over here on their own. So you can get for $10 or something a cable chain that will mount and basically house those cables and keep them from going anywhere. This cable chain can only go up and down basically, or it can't move side to side. The only reason I'm hesitant about putting it on right now is because I started printing a red one that matches all the other stuff. I didn't get enough pieces of it made to go very far yet. But you can print these things too. In some cases it might be easier just to buy the one because it's not expensive. But I didn't think about it, but I kind of might want it to be red with all the other stuff being red. So all it would do is it's going to bolt into the little grooves, the V grooves in the frame that are already there, using this kind of thing, where you've got the T-nut again that we used to mount a couple of, basically the Z-end stop was mounted that same way. And then it'll screw into the bottom of the stepper motor, or maybe we print a bracket or something. Maybe we redesign this whole thing so that it actually holds our cable chain and this guy better. So I don't know if I want to put it on just yet, because I might want to either get a red one or finish printing this one red. So I think what we'll do instead is we'll work on this, and that'll probably give us all our time for today. So like I said, originally these Ender 3s, and this still is, this is plastic, all this is plastic, and there was a big problem with the filament. Let's get it out of the way, can't move it now. The filament basically rubbing a groove right here where it came in at, because it was normally coming in from the top and basically riding in here and cutting a groove in here. Now they've at least put this metal brass piece, we need to lower it a little bit, brass piece in here that stops that, but these are still plastic. I don't know, they're probably fine, but I do have a metal version of the same thing. So this is metal, and it's just, you unbolt this one, you bolt this one on top of it in place of there. So I think we're going to do that just because. Again, this is another one that's not super important that you do. It used to be, particularly if yours doesn't have the brass insert there, then yes, you do need to keep an eye on that, because it will over time cut away that piece, and then you have to change something for sure. Just the guides will help. If you don't have the brass piece, you can print like something like this one. I'm not so sure I like this one though. We'll work on it and see, and print something like this one at the top, and just make the filament come in at a less severe angle. Gotta find the right size key here. There we go. Let's see if we can. Now the screws that hold this on are also the screws that hold the stepper motor on, so make sure you don't let it just fall when you unscrew all this stuff. There is a pretty strong spring in here, that's why it's kind of giving me problems. All right, so on Friday, what we're going to do is we're going to look, mostly we'll be in Cura again, and actually we will, I think we will also go in and look at some calibration things. For the Ender 3, that's a little bit not as straightforward as it is on some other printers, so we may have to break out our Arduino and do a little bit of Arduino work. I don't know if we'll want to do that. I might save that for a whole day by itself though. But we will at least work on the calibration that you can do without changing the firmware down in here, which is on some printers it's super simple. On the Ender 3 it's got a little bit more work that you have to do to get it to modify any firmware. So I don't know if I'll want to tackle that with other things or not, because it does take a little bit of extra work. But it's not terribly hard to do. It's just more to do. So there's 4 screws here that are holding these pieces on and holding the stepper motor to this little bracket. So you do have to be careful that you don't just blindly take all these screws out and then the stepper falls and messes up your new PEI bed. Oh, and we can get a look at the little gear here. So this, now the one I have came with another one, so a little bit different. It's got much bigger grooves in it. So this, what happens is stepper motor, this is the extruder motor, so it's going to be turning, sending filament into the hot end. And so these little grooves in here basically grip onto the filament, and they pinch it between this groove and this little roller inside here. And the spring applies tension to, you know, make that pinching actually happen. So I might, actually, this one's pretty beefy. You know, it's got some much bigger, deeper grooves. I might actually use this one versus the one that came on it. I don't know. These grooves can get filled up with plastic. Basically, they're chewing away the plastic as they're printing. And so if these ever get filled in to the point that they're basically solid with plastic, then you'll get a lot of skipping. It won't, in other words, it won't be able to actually force the filament in, because it's just going to not get down in the grooves to grip a hold of it. So if you ever have skipping or anything like that, check out these little grooves. And if they are filled with plastic, you need to get you a tiny little screwdriver or whatever and, you know, clean each one of them out. Obviously this one's only printed one part, so it's not filled up yet, so it's still okay. Let's see if we can get our part, new plate. So this is all metal. It did come with its own screws. I don't know if I want to use them or the ones that were part of the other old one. I don't know. I guess I need to make sure they're the same screw thread. They do look like they are. Most of these different screws and screw threads are all the same from printer to printer. So you don't have to worry about that too much, but if you do get an upgrade kit that has new hardware, you do need to make sure that it's the right kind of hardware. This one uses a Phillips screw for some reason. The others are all hex screws. Gotta get it to line up though. I notice I didn't change that out. I'm still debating on whether I want to use the old one or the new one. The new one definitely is much more aggressive in its tooth profile. It's got much deeper grooves, so they'll be less likely to clog up, and there are fewer of them, so if I ever did have to clean them, there's fewer to clean. But I don't know. to change it out, there's just a tiny little set screw that we, oh actually this one has 2 set screws, so this one only has, no it does have 2, but it's missing 1. So if I, oh there it is. Alright. That's going to take some very fine motor skill to be able to do. How these work, you don't have to even remove them all the way, you just loosen them and then this will slide off of there. This particular shaft does have one, and most stepper motors do have one side that's flat, and so you want at least one of those set screws on the flat side. Obviously they can't both fit on the flat side, but one of them can. Now you have to set the height, so the filament is going to come in and it's going to have to exit this hole right here, and so you do want the height of the threads more or less so that they're centered on that hole. So I've got this one a little bit high, not a lot, just a little. So I want to lower it and maybe right there. All right. And then we do need to put that other set screw in. One is probably fine, but we have 2, so we ought to put 2 in. All right, so that's changing that guy out. And then we got to put, now this part, it came with a spring, and the spring it came with is this darker one. It's a little bit shorter. I'm going to use the longer one that came with the original printer, just because the shorter one I don't think it's going to apply enough pressure. That spring is what you have to pinch it together to release the filament, and it's what's applying pressure between the bearing and the hobbed screw here. Not hobbed, but the screw there. Even this one, well, let's see where it ends up when we put this screw in. Wow, I might have to get a smaller screwdriver. In fact, I think this one's too big. Okay. Now, on this screw, this is the pivot screw. I've seen plenty of times, even from the factory, where this has been so tight that this basically isn't doing anything, and it's tightened down to the point that the filament isn't being pinched between the roller and the tooth bearing here, and if it's not pinched together tight enough, basically if this is holding it away too far, then it will be very easy for the filament to skip or not be driven into the system. So if you're having skipping problems or under extrusion, and it's not any of the other things we've talked about with the heat creep, or something's tangled or whatever, which mine is a really bad mess right now because I've got it kind of loose, then it's possible that this screw has been tightened too much, and it's not letting this pivot freely. It basically you should be able to push it in, and then it should spring back to apply the pressure between the things, which actually I'm not totally sure it's doing. I'll have to check and see once we get filament in there. Let's see. And again, there it goes. Yeah, see, so the way that this is set by default, there's actually no, I can easily, without doing anything here, move the filament in and out. So that would not work. And I think the problem actually is they have got a little, basically looks like a nozzle. It's not a nozzle, but it looks like a nozzle on this side to receive the filament. And I think it is colliding with the bearing. the roller bearing on this guy and not letting it pinch all the way against the film. Yeah, I can't even. I could apply enough force, but that's a lot of force. So what I think I'm going to do is I think I'm going to take this back off and take that little nozzle that they have. Most of them don't have that nozzle. That's the first time I've actually seen one on this kind of change. I think it's kind of in the way, basically. But we're pretty much out of time, so I'll do that off camera, and I'll decide something with this guy. I like the idea of, you know, not making the filament come in at a right angle here, but the way that this one is actually working is not working the way I want it. So we might rethink this guy. Okay, so we will come back to that on Friday and look more in our slicer, do some more prints. Maybe at that point I will have decided what to do with these cables so that they're not all in the way. That this one does not have the little clip here that you could clip this onto. So now I really do have to figure out where this is going to go if I stay with this one. I do like that it's all metal. Not sure I like that it's got a kind of bit of collision in there that's not working right. Okay, so we'll be back on Friday, do some printing and some things in Cura, and see you on then.